Alright, you are welcome to this lesson, and in this video you have been asked to find the value of k so that the following function is continuous everywhere. Now the first thing we do is that we use the condition for continuous to check and see what is happening here. So first let's check what is f of a. That's our first condition. Now f of a must be defined. Now what is our a? You see x equals 1 and this should be equals to your a, should know that. Now f of a will be equals f of a is 1 which is equal to, where do we have x equaling 1? Yes, is x not equal to 1? Yes, is x equal to 1, and f of 1 is equal to 2. That's our first condition. Now second one says that the limit must exist from both sides. The limit as x approaches a from both sides, from the left, must be equal to the limit as x approaches a from the right of f of x. But we don't even know what this k is, so let's just see what is happening here to find the limit to begin with. X approaches 1 of f of x will be equal to kx minus 3 all over x minus 1. At x as 1, we have k1 minus 3, 1 minus 1. Now you are already observing that this is undefined. This is undefined. Now we'll get k minus 3 all over 0, which is an undefined fraction. So now you notice that whenever we get something like this, we always look for a way to factor the numerator so that we can cancel out something here at the end, right? Now this k should stand for a value in which when we factor it out, we can cancel x minus 1 out, because you can see that as x equals 1, you get what we call discontinuity, and that type is called removable discontinuity at x equals 1. So we have to find our way so we can cancel out x minus 1 and take away the error. So at this point, all you have to do is set k minus 1 to be equal to 0 if you have any question like this. So we have k minus 3 equals 0. This will now give you, this will imply that k will be equal to 3. So as k as 3, we can factor out the top. So we have limit as x approaches 1 of f of x to be 3x minus 3 all over x minus 1. So we have 3 into x minus 1 all over x minus 1. So we can cancel out x minus 1 and x minus 1. So we'll be left with just 3. So the limit as x approaches 1 of this function of f of x is equal to that. So we have that there. So which means that the value of k is 3, and let us see if it's still continuous. So you can see that the third condition will fail because f of 1 is 2, but this limit is giving us 3. So the limit as x approaches a from either side of f of x does not equal f of a, which means that this function is discontinuous, and it is what we call a hole discontinuity. Now how can we fix a hole? All we have to do is redefine our function so it corresponds with this limit and is continuous. So if you want this to be continuous and you want to fix it, all you have to do is redefine f of 1 to be 3. That's all. So just redefine f of 1 to be 3 and put 3 here. Then all you have here will be continuous. Thank you, and see you in the next video.